radical or square root sign with a 4 on the outside, y to the 8th power. The fourth root again will be a number times itself 4 times, and we want that to equal y to the 8th. When doing radicals of variables, one way to solve is to take y to the 8th and write the y out 8 times. And if you remember from square roots, you normally count the pairs, but since it's a fourth root, we'll count sets of 4. We'll have the first set of 4 and a second set of 4. So since we have 2 sets of 4 and we're doing the fourth root, 2 sets would be y to the 2nd power. And what that means is y squared times itself 4 times would be y to the 8th. And last question for the section. The fifth root. And the fifth root again is a radical sign with a 5 on the outside. And inside the fifth root we'll have 32 x to the 5th and y to the 10th. So taking the fifth root of 32 x to the 5th, y to the 10th. Doing the number first. Again, the fifth root means a number times itself 5 times, that's 32. If you think about the numbers, that number would be 2, since 2 times itself 5 times would be 32. For the variables, if we want the fifth root of x to the 5th, we can either write out x 5 times, or we can also divide. 5 divided by 5 would be 1, meaning there's one set of 5. If we do y to the 10th power, and again you can divide the exponents, 10 divided by 5 would be 2, and what that means is if you write out 10 y's, there'll be 2 sets of 5. So our final answer would be 2 x y to the 2nd power. Title of the next section is Radical and Exponential Forms. In this section we'll look at radical forms and exponential forms and how to change between the two. One definition or formula for this section. A radical sign will have the c root on the outside, and inside we'll have a to the power of b. So the c root of a to the b is equal to a to the exponent of b over c. So taking a radical form, we can take the exponent inside divided by the root number, or we can also take the exponent form and take a fraction with the numerator and denominator, with the numerator being the exponent and the denominator being the power of the root. First question we'll look at is the fourth root of x to the 3rd power. Taking the fourth root of x to the 3rd, we'll switch this radical form into exponential form. Matching the numbers up, the x, which is the variable a, would stay the same, and the fraction would be b over c, or in this case 3 over 4. So the fourth root of x to the 3rd power is the same as x to the power of 3/4. Second question, the fifth root of x squared y cubed. And again, taking a radical form, we can switch it into exponential form. Since we have 2 variables, we can compute each separately. The x again would stay the same, and making a fractional exponent, we'll have 2 over 5 or 2/5. The y would be our second variable. And again, taking the exponent over the root number, we'll have y as 3 to the fifths. So changing the form, the fifth root of x squared y cubed in exponential form is x to the 2/5 times y to the 3/5. Next question. In exponential form, we'll have 2 to the exponent of 4 over 9. This time we'll take exponential form and switch it into radical form. Again, the 2 would stay the same inside the radical. The numerator 4 would be the exponent, and the 9 would be the root number. If we have a number to a number, we can simplify that exponent. The 9 would stay the same, and 2 to the 4th power would be 2 times itself 4 times, which would be 16. So 2 to the exponent of 4 over 9 is the same as the 9th root of 16. And last question for the section, x to the 1/2 power. And again, taking a question in exponential form, we can switch that into radical form. The x again, the base, would stay the same. The 1 would be the exponent, and the 2 would be the root number. The 2 on the outside represents a square root. If you have any other number than a square root, we can leave that on there. If we have a 2, you can take the 2 off. A square root is the same as the second root, and x to the 1st power would just be x. So again, switching x to the 1/2 power is the same as the square root of x. Title of the last section today is Simplifying Expressions. In this section, we'll use radicals and exponential forms to simplify expressions. First question is 16 to the 1/4 power. Looking at 16 to the 1/4, there's no way to multiply 16 1/4 times, but what we can do is change that to a radical form and then simplify the radical. 16 would stay inside the radical. The 1 would be the exponent, or just leave it at 16, and the 4 would be the root number. The 4th root of 16, you can either think about what number times itself 4 times is 16, or you can do factor trees, such as 4 times 4 and 2 times 2. And then we'll have 4 sets of 2, so the 4th root of 16 would be 2. Second question, in parentheses, negative 27 to the exponent of negative 2/3. Simplifying first, if we have a negative exponent, if you remember from previous sections, a negative exponent means we'll do the reciprocal. So a negative exponent instead of negative 27, if we do a reciprocal, writing this over 1, the reciprocal would be 1 over negative 27, and by doing the reciprocal, the exponent would change to a positive 2/3. Simplifying from here, if we have a radical or fractional exponent, we can change that to a radical. The fraction again would stay the same, 1 over negative 27. The numerator 2 would be the exponent inside the radical, and the 3 would be the radical 3rd root. Simplifying from here, you can either multiply 1 over negative 27 squared, Or if you want to, you can write the same fraction twice. 1 over negative 27 times 1 over negative 27. And instead of multiplying straight across 27 times 27, we can just take the third root of each number and then multiply at the end. For example, the third root of 1 would be 1, since 1 times itself 3 times is 1. The third root of negative 27, which again would be a number times itself 3 times, that's negative 27. And that number would be negative 3. And the second fraction, since it's the same fraction, will be the same answers. The third root of 1 would be 1, and the third root of negative 27 would be negative 3. After taking the third root, we can multiply the fractions. Multiplying straight across will give us the answer of 1 over 9. Next question. In parentheses, a to the exponent of negative 2 over 3 times the exponent of negative 1/6. And again, with negative exponents, we can do the reciprocals, or since we have a power to a power or exponent to an exponent, we can combine those. And if you have a power to a power, we'll end up multiplying negative 2/3 times negative 1/6. Multiplying will become positive, and 2 times 1 would be 2, and the denominators 3 times 6 would be 18. Reducing fractions, 2 over 18 will have the exponent a to the 1/9 power. We can leave answers in exponential form as long as this is a reduced fraction and it's not an improper fraction. If you have an improper fraction where the numerator is bigger than the denominator, we can change that to radical form to simplify. As long as it's a fraction in reduced form, we can leave it as a to the 1/9. And last question for the section. Square root of 17 times the third root of 17 squared. Simplifying from here. If we have two radicals, we can multiply the radicals if they're the same root. This is a square root times a cube root. Since they're different root numbers, we cannot multiply them straight together. But what we can do is change each of these into exponential form, and with the same base we can combine. For example, the square root of 17 is 17 to the first power, and the square root, or if there's no number written, we can add a 2. Changing this to exponential form would be 17 to the 1/2 power. Multiply. Changing again the second radical into exponential form would be 17 to the exponent of 2/3. When multiplying exponents, if we have the same base, 17, we can combine the exponents by adding those. So our answer, 17, will remain the same. And adding the exponents, 1/2 plus 2/3. If you change those to common denominators, which will be a 6, 1/2 would be the same as 3 over 6, and 2/3 would be the same as 4 over 6. So 3 over 6 plus 4 over 6 would be 7 over 6. And again, you cannot multiply radicals if they have different roots, but changing them into exponential form, we can combine exponents as long as they have the same base. And again, exponential form, fractions are okay, but if we have an improper fraction, like 7 over 6, we can simplify that by putting it back into radical form. 17 would be the base, 7 would stay as the exponent, and 6 would be the root. When you have an improper fraction, meaning the numerator is bigger than the denominator, that means you'll have more pairs than the pairs you're looking for. For example, 17 to the 7th power, instead of multiplying it out 7 times, we can just write it down 7 times. And since it's to the 6th exponent, we'll be looking for pairs of 6. with one pair of 6, that means 17 would go outside the radical sign. The radical would stay the same, the 6th root, and we have a single 17 left over. So 17 to the 7th power, taking the 6th root, is equal to 17 times the 6th root of 17. And again, when you have fractions, improper fractions, where the numerator is bigger than the denominator, you can always take out at least one pair to simplify in radical form.